Welcome back. This lesson's called Proving Triangles Similar. Now, before you get all hot and bothered, when you see the word proof, we're not writing proofs. We are done with all of that. All we're going to be doing today is looking at shortcuts and just like saying, oh, this shortcut would work. This shortcut would work. So not proofs. All that's behind us. Let's remind ourselves first, though, last lesson, we talked about what does it mean if two shapes are similar? And remember, there was two identifying properties here. And one was that they had congruent angles. So angles that go together are the same. It was the sides that made similarity different from congruence. And it's that the sides were proportional. And that whole idea, I think makes this stuff challenging. You throw congruent in there and it'd be way easier. The proportional side, that's what makes it a little bit tricky. So last lesson, to say that two shapes were similar, we had to check all the sides and make sure they're proportional. And we had to make sure all the angles were congruent. So it's kind of a lot of work. Today, we're cutting that work down with shortcuts. Remember that with congruence, there were 5 shortcuts, like HL, SSS, SAS. There's 3 shortcuts that prove triangles are similar. Okay, we're talking similar now, not congruent. So there are 3. They're going to look really familiar to last unit, except for this first one. The first method is called angle-angle similarity. So we're going to abbreviate that AA and then a little squiggly similar sign. Now, what this says, and this is my favorite one because it's way easier than the others, but basically all it says is that if you've got 2 triangles and if there's 2 angles, because it's AA, if 2 angles of one triangle are congruent to 2 angles of another triangle, you don't have to check the sides and their ratios at all. This one's awesome because I don't have to mess with fractions. If I've just got 2 pairs of angles, that's enough to prove that the triangles are similar. So check it out. Here's an example. I see 2 triangles. I see 1 pair of congruent angles. I see another pair of congruent angles. Technically, that third pair is going to be congruent because of third angle theorem. Who cares about that though? As long as there's 2 angles that are congruent, I'm done. I know these triangles are similar. My reason would be AA similarity. So all I'm asked is to write a similarity statement. So something like maybe triangle TRS is similar. Watch your order. I went 1 mark, 2 marks, no marks. So I'm going to go 1, 2, none, and say PLM. No proofs, just identifying which shortcut it is. So sounds easy, but when we throw sides in here, it does get a little bit more challenging because you have to test fractions. But method number 2 is called side angle side similarity. So we'll say SAS and then that little squiggly. You've seen SAS before, but the sides part, again, that's going to make it different here. What this method says is that if 2 sides of one triangle are proportional, I hate that word, hate testing fractions. But if 2 sides of one triangle are proportional to 2 sides of another, and the included, this part's weird, the included angles are congruent, because I know sides are proportional, angles are congruent, but the included angles are congruent, then that's enough information to say the triangles are similar. So the included part, don't get weirded out about that. I think you guys would look at these triangles and say, oh, look, SAS. You would still see SAS like we did last unit, I hope. Included just means it's like the angle between the 2 sides. So don't get weirded out by that. But here's where this just gets a little bit more challenging. You can't look at it and see SAS or the next one. You've got to do some work to figure out the side part. And they're asking me, hey, why are these 2 triangles not similar? So let's piece that together. I do see that the information is in the right order, SAS. I've got that congruent angle, those are both 90, but I have to test the sides, and by test I mean write a fraction, to see if it's the same fraction, those two side lengths, the corresponding sides, they have to have the same fraction to be proportional. So watch. 3 and 6. Those sides go together. I'm going to make a fraction out of it, and I'm going to reduce that fraction. So these sides are in the ratio 1 to 2 or 2 to 1. Doesn't matter which one you write on top. Be consistent. 4 and 10 go together. That reduces to be 2/5. Those are not the same ratio. Therefore, these side lengths are not proportional. So these triangles are not similar. Okay, the last method, method number 3, is side, 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 similarity. We saw side, side, side last unit, so that's not going to weird us out. I see all 3 sides are kind of labeled here, but here's the difference. Again, the sides have to be proportional. So you're going to have to do some work probably to figure that out. You can't just look. So if all 3 pairs of sides are proportional, then that's enough information. Don't have to care about the angles at all. That's enough information to say the triangles are similar. So let's go ahead and show that the sides either are or are not proportional here. Basically, I just have to figure out which pairs of sides go together. So I think a lot of us would say like 4 and 6 here. Those go together, so make a fraction, 4 over 6, and then reduce it. So you can divide both of those by 2. So those sides are in the ratio 2 to 3, 2/3. Do the same thing with the other sides. So like this guy and this guy. That's easy. 2 over 3 already reduced. This bottom pair of sides here, this might weird some people out, but watch, I'll show you a trick in the calculator. So if you have a decimal within your fraction, I let the calculator do the work for me. I just divide those, and it's going to give me a decimal. Maybe you recognize that's 2/3, maybe not. But right here above this PRB button, it says like F to D. Press second, that button, and it'll change it from a decimal to a fraction and show you that that's just 2/3. So check it out. These all reduce, all 3 pairs of sides, to be 2/3. That means that they are proportional. So these sides are proportional. The triangles are similar. Woo, a lot of info. Okay, I'm going to highlight the 3 methods so they stand out a little bit. Your notes, do what you will. Okay, one thing to note before I show you a few examples on the back. This is a big note too. There's like confusion about this every year. If you're given a picture, you have to prove that the triangles are similar before you can go and find a missing piece. And by missing piece, I mean like a missing angle measure, or set up a proportion to find a missing side. Okay, if these triangles are not similar, I can't do anything to figure out the missing pieces. It's only when they're similar that I can apply what I know to find a missing angle or side. So be careful there. All right, few examples here. Let's do this. Example 1 says, find the length of ST if possible. Possible. Now, here's what you got to do. Like I just noted, you have to figure out if the triangles are similar before you can find a missing piece. So if I determine these triangles are not similar, I'm going to stop and say, I don't know. I don't know what it would be, because I can only find those missing pieces if these guys are similar. And to say if they're similar, I'm looking for one of my 3 shortcuts, my 3 methods. So you have to start there, which I know is kind of a lot to process. So if I look at number 1 here, check your order like we always did with congruence. I see SAS. Over here though, I see ASS, ass. That does not work. If this 8 was down here, then it'd be SAS, and then I could test the ratios to see if SAS actually applied. But guys, if the order isn't what you need it to be for one of these shortcuts, don't do anything. I have no idea if these are similar. I can't test this. So honestly, some of these might be nice because I don't know. I can't test SAS, the order's not right, so None of those shortcuts apply. Don't know if they're similar. Move on with your life. That's kind of nice. Hopefully a lot of them work out like that. Okay, on the next one. So I'm going to step back and kind of think, can I test one of these shortcuts? If I just looked at one triangle, I see ASS, which is not the order I'm looking for. But I do notice beyond that one pair of congruent angles there, I see that this picture would have vertical angles. So check it out. I've got one pair of congruent angles, two pairs of congruent angles. So angle, angle. This is proving that these guys are similar. Proving. You don't have to write a proof. So sweet. Angle, angle tells me these are similar. Now that I know they're similar, I can find missing pieces. And the missing piece I want to find is X, which is a side. And to find a side, like we did last lesson, you set up a proportion since these sides are proportional. So be careful here. Let's see, 24 and 14 go together. So I'm going to go 24 over 14, big over little, then come back here to the big triangle and go big over little. A lot of ways to set this up. You could do 24 over 22 equals X, 14 over X. Just be consistent and put pieces that go together in the same slot. All right, cross multiply and divide here. So 14 times 22 divided by 24. 12 point, that's not nice. That's okay. I'd count that. Or I can change it from fraction to decimal. That's 12 and 5/6, if you care that much. Either answer is right. All right, next one. So find the length. And again, when it says if possible, I have to say if they're similar or not first. These are overlapping. We saw that last unit. The small one is a triangle. The big one is the other triangle. So my advice is always going to be like redraw them. It's going to help you. On the yellow triangle, this whole side, be careful, that's 18. Got to add those pieces together. That's hard to see. I'll write that in with purple. And this is 27. Okay, so on the yellow guy, it's 18, 18, and 27. Now, take a step back. Remember when the triangles are overlap, they share something. And they share this top angle N. So if you look at this, let's get a new color. I don't have angle, angle. There's only one angle. I do not have all the side lengths. I don't have this guy. So I cannot test side, 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 but I can test side, angle, side, because I've got that order on both of them. Got that included angle. And I see if I test the ratios, it's 8 over 18 and 8 over 18. Who cares about even reducing them? That's obviously the same fraction. So SAS proves that these guys are similar. So now I can find a missing piece, and I want to find MP. I'll call that X. Okay, I want you guys to set up a proportion to find X right here, or find MP. Make sure you write in the correct answer. All right, the last one here before we do a random one at the bottom. Let's see, so measure of angle J is 29, L is 34. What's the measure of angle Q? Well, these guys have to be similar before I can say what that measure is. So I see I'm given all the side lengths, so I can test side, side, side. Let's see if it works. So 60 and 40. And I can divide both of those by 20, so that would be 3 over 2. Okay, be careful here. So the remaining two sides, when they flip it, it's kind of weird, but like 22 is the smaller of the remaining sides. 32 is the smaller of the remaining sides. I don't know if it bothers you that I did the big one over the small one. I don't know, it kind of bothered myself. Yeah, because I don't like that, so I'm going to convert that. Oh, that's 16 over 11. Duh, divide them both by 2. So like those are not the same ratio. So that tells me that side, side, side's not going to work here. I can't do anything. I don't know if these guys are similar. So like stop right there. I'm done. And guys, we'll do that last example together in class.